Hello, everyone. Very good evening to all of you. Welcome to today's webinar session, How to Use Energy Simulations as a Design Tool. Clearly, it's a very interesting topic, and there's so much to know about it. Even if we are using energy simulations, there is still so much to discover and learn about it as we progress or move forward in our journey of working in whichever roles that we play, maybe a consultant, maybe a architect or a design professional, or maybe a construction management professional, and so on. So today we're going to talk about the how to leverage energy simulations, what are the different options available, and really we're going to speak from our own experience of having used these tools pretty much every day, or I would say in most of our projects as consultants. So I'll just share my screen. So I'll introduce myself, and then Gurneet, you could introduce yourself and take it from there. First things first, everyone should know who is it that you are listening to. My name is Deepa. I'm an architect and a green building consultant. I've been into consulting for more than 10 years. I work on a lot of high performance building design projects, giving inputs on the design side, setting performance targets for projects. I also work on a lot of policy and research projects. And I lead the training and capacity building vertical at EDS. I'm joined here by my senior colleague, Gurneet Singh. Gurneet, over to you.
Yeah, thank you, Deepa, and good evening to everyone. I welcome you all to this webinar and thanks for joining in. I am Gurneet. I am Director at Environmental Design Solutions. I work on different kinds of projects from high performance building design to ESG, GRESB rating, and also look into policy and education and training. So I welcome you all. So briefly we'll give you an update about EDS. So we are a sustainability consulting firm which work in built environment. So if there's anything related to sustainability in buildings, we provide that input. Next, Deepa. Yeah, so we started in 2003. This firm was started by Anamika Prasad, my senior colleague. We at present are a team of around 65 people, and we have executed around 400 plus projects. So Deepa, maybe can you just move to, yeah. So we are a team of 65 and we have executed around 400 plus projects. Yeah. So this slide basically briefly summarizes the kind of services that we provide. The first one is high performance building design, which covers certification, net zero energy building, looking into existing building audits. The second one is policy advisory services, where we work with the government agencies, multilaterals, bilateral organizations like UNDP, USAID, CLASP, and we provide inputs on, we help them develop manuals or any help them develop standards. Also in this, we provide consultancy to different organizations on the ESG front, the environment, social and governance front. So that all is covered under policy advisory. The third one is commissioning and audit. This is related to existing building. So we all know that, existing building has got a huge potential, and the best way to achieve energy efficiency is to first see where we can save energy, so that there the audit and commissioning part comes into play. The Fourth one is building performance simulation. So looking into energy, daylight, CFD simulation, exploring different tools. Those are covered under building performance simulation. The fifth one is technology services. We look into developing dashboards, IT tools, but again, the scope or the boundaries are related to buildings. So like we developed a dashboard for monitoring 200 homes across India to understand what is their equipment usage, so that that can help the in future the policymakers in that part. And the last one, I think most of you are aware of that. We are into capacity building and education. That's sustainability education. So we have developed various online self-paced course. We conduct blended learning programs, and there are live workshops also we conduct for corporates and general public, right? Okay, so I think Deepa, this you can take.
Yes.
Yeah.
So that was a little bit about us. And if you have any more questions, you can, of course, send it in the chat or raise your hands to speak. So let's get to know you a little better. So, I'm going to launch a Zoom poll and it will show up on your screen. Please send your responses through this poll question. So the first poll question is on your screen. What is your experience in using energy simulations? There are 4 options there. Select the one that fits, the best, what you think is the most fitting answer. There are 4 options. I'm getting started. I know many tools,
And
but not.
I would say not only energy simulation, so any kind of simulation, whether it's daylight or any kind of simulation.
Right. Right. So there are 4 options. I'm getting started. I know many tools, but I'm not actively using them. I use simulations frequently. And the 4th is I only use them when a project calls for it. So I think just a couple of them are yet to answer. All right. So except maybe one person is yet to answer. Everyone else has answered. I'm closing the poll now. And here are the results on the screen. Are you also able to see the results, Gurneet?
No, I am not. I'm so there is a I am able to see the results. Right?
Okay. All right. So 58% of the audience saying I'm just getting started.
Right.
Right. And then we have pretty much an equal sort of distribution between I know many tools, but I actively don't use them. Then I use simulations frequently, 16% of them. And very few percentage of our audience is saying that they only use it when a project calls for it. That means they are using it pretty frequently. Yeah, so that's good to know. Now, a second follow-up from here will be a mentee question. So I'm going to share. I'm going to put a link in the chat for all of you. So please click on this link and it will take you to a Mentimeter poll. And you can send in your answers in that poll. So I'm just going to share the screen so you can see the poll answers as well. Okay, so the question is, which simulation tool software are you using currently at your work, study, or research?
I think, Deepa, the link is not the correct one.
Is it? Copy link. Okay, let me put this again. Oh, yes, sorry. It is the Insta module link. Sorry. Yeah, Menti link. Please ignore the first one. Here is a Menti link in the chat. Please use that. All right. So when you log in, you can use your phone or your laptop. There you go. And there is a box in there for you to send in your responses. You can send them multiple times as well. Okay, so let's look at the different tools that our audience here is using. So there's Design Builder, Revit, Ladybug, Honeybee, eQuest, Ecotect. So even if the tool that you're using is already here on the screen, please send in your response again. So we know how many of you are using probably the same tool. So looks like Ladybug is more popular here. Okay, any more tools? Where some more people are yet to log in. Okay. eQuest, Design Builder. All right, Revit tools as well. Open Studio. Of one of you is using Open Studio. Okay, so here are a bunch of tools. So 26% of you said you're using it frequently. No, 16% of you said that you're using it frequently. Okay, let's go to our next question. The link remains the same. Here is the next question. What are the challenges when you are using simulation tools on a project? Some of you said you're just getting started. Maybe your challenges are different. And some of you said you don't use them very often, although you know them. So maybe your challenges are different. And those who are actively using on projects, maybe your challenges are different. So just send in your responses. You can type it into the box. So Kiran, I've gone to this next slide. See, I can already see some responses here. Let me send this link to you again. Oh, now you can see. All right, great. Okay. Okay, so all right, send in your responses. Okay, data entry is a challenge. Not started. Not started with simulations. Is that what it means? Okay, some of you are sending in the chat box. Minimum system availability. Okay, can't do quick model. All right. What else? Tool knowledge can be a limitation. All right. Heavy file. Do you mean simulation model? Maybe. Heavy file slows down the simulation. Yeah. Simulation results verification. Probably that's what you mean. And if you're not facing any challenges, you can say that too, that this is not applicable to you. Thermal simulation, HVAC optimization is a challenge. Okay. So that relates to the tool knowledge, right? Processing time. All right. Processing time could be a challenge for those who really know how to use the tool, right? And tool knowledge could be a challenge for those who are starting out. Unexpected results. Okay. What else we have? Simulation results, data entry. All right. Any more? You can even send it in the chat if you're not comfortable with the Menti interface. Okay, so I guess we'll stop here. And I want to go back to the PPT. Right? Yes. Okay, so we saw different challenges that you are facing, at least some of you who have shared when using simulation tools on a project. Now, would anyone like to speak about it? and elaborate on the point that you shared on Mentimeter, you can raise your hands, and you could, so we could allow you to speak. Or maybe I'll just allow everyone, and then you have an option if you wish to unmute and speak. Yes. Levent, would you like to share something? Okay. Krishnendu, would you like to share something?
Yes. So I was working with one of the UK overrating assessment projects. According to the thermal TM52 reporting, right? And I was finding it difficult to assess the results, and I was quite confident about the settings through which the results would come, but the results were not as I was expecting. The building was showing it is getting way more overrated than I was assuming. So yeah, this is what I felt. Then eventually I had to change the HVAC system, but I was quite confident because I was quite confident on the previous system that it would help, but that didn't.
So you mean to say the results didn't sort of align with your expectation of
Yes,
how the
yes,
performance should be?
yes.
Okay. So all right. So that's one of the challenges. We face that all the time as well. That is very common. Anyone else? Would you like to share? Okay. So, okay, I don't see any more sort of hand raises, so that's fine. We can move forward.
Yeah, so Krishnendu, as Deepa said that, and this is a challenge that we also face, where the results are not in line with what we expect. But yes, if you think and if you feel that, that system should work in that climate conditions, then maybe we need to basically debug or see maybe one or the other input parameters or the controls may not be modeled properly. So yeah, that's a challenge, and there you need to get into the whole system and see how that system is working, simulation tool is working, and whether those parameters are modeled correctly or not. Now moving to Deepak and yeah. So as we all know, for any building, first and the foremost thing is to achieve comfort, whether it's thermal comfort or visual comfort or sound comfort, acoustic comfort there. So comfort is important, and at the same time, energy optimization or energy savings is important. So a combination, if we are able to achieve both, that is equivalent to the performance holder. So you can't measure the performance, or you can't say that your building is performing good only on one of the parameter like energy or comfort. So you need to take both of these together. Can you Yeah, and this performance can be evaluated or validated basically using software tools. When I say evaluated, that means before the building is completed, done, you can evaluate both the performance that is looking into comfort and energy. And once the building is complete or is in operation, then you can actually validate whether the building is performing good or not. Next, please. Yeah. So these performance goals can be at a building level or at a component level. So you can say that overall, I want to achieve certain energy performance index, so that is the metric that I am trying to use, that is kilowatt hour per square meter per year. or you can go by an absolute number that, I would like to achieve certain, I would like to be lower than certain threshold in term at a building level, right? Or you can go at a component level. That means, okay, uh, you are not getting into the overall energy use, but yes, you want to have a glazing which will be shaded throughout the year, or during summer months, right? So glazing is one component, shading is one component. You can always set a performance goal for that individual component level also, right? Yeah. And yeah, next. And this is basically is the potentials of various design strategies. So it basically you can achieve 50%, up to 50% uh, savings through design strategies, right? Rest 50% is a combination of uh, energy efficient technology, or getting into energy resources. And what are these design strategies which can help you achieve this reduction? Looking into solar geometry, looking into daylighting, natural ventilation is very important. How the thermal mass of the building impacts the energy usage, comfort conditions, looking into shading and glare, looking into components of passively heating or cooling the building, and definitely looking into thermal bridging. And based on these performance parameters, you arrive at the design decisions. You arrive at that, what should be the optimum form or orientation, or what should I keep the floor to floor height. That will also define your structure system, wall design, and the facades. Next, please. So these are few examples of good buildings. So this is a picture of a School of Design and Environment at NUS. This building has achieved zero positive energy balance. You can see that it has got a great roof. All the glass is shaded. So they have used a various combination of passive measures. They have optimized their active systems, and they are generating or offsetting whatever energy they are consuming through solar energy and different strategies. Next on your left is our Humanscape. This is basically a net positive energy housing complex. Again, an experimental housing complex situated in Oroville. It is a sustainable housing complex. Basically, they are trying to create and study the future model of sustainable living. On your right side is of Sara Academy at Pune, which is a residential school complex. Uh, uh, this, through its design, climate responsive design, the project has achieved comfortable internal conditions and is almost nearly net zero. And through only design, achieving the thermal comfort, they are not using any mechanical system. Uh, Despite the climate in this region is warm and humid type. Next, please. This one is ASHRAE headquarters at Atlanta, USA. Again, a building which is net zero. Again, you can very well see from the picture. They have used various passive design measures in the project uh, to reduce their to reduce their energy usage and achieve net zero status. Next, please. This is not a net zero energy building, but yes, this is a project. You will not see any building nowadays which uses such kind of shading. So they have used shading. The idea was to block direct sun hitting coming in. So they have actually achieved that. So not even for a single day or single hour, the sun enters the office space. Next, please. And this is the internal view of the same building. So generally, whenever we suggest shading, the first thing come from the architect or the client is that it will block the view. And you can see now, with such a heavy shading also, there is no, you can still get a good view of the outside. Next. Yeah, one of the interesting thing I would like to share on this, when we are talking about comfort, yes, shading was to block the direct sun, which has a direct impact on energy, but it also has a thermal impact on the thermal comfort. And I just want to share that, we got a feedback when they were implementing this shading during construction. What we observed, the workers preferred working on the floor where the shading was implemented, because those floors were, cooler or provided a thermally comfortable environment compared to the upper and the ground floor. So that was, just a validation of that, how a shading or climate passive design can achieve a comfortable environment, and at the same time can help you with energy savings. Now, we all know about COP26, India and India's commitment at COP26. So majorly they were like, one of the commitment was to achieve net zero by 2070 and achieve a reduction of 45% in carbon intensity by 2030. And you must have also observed in different seminars that buildings play a very, very important role in this thing, because they consume a lot of energy. So it's important to, as a designer, architects, as electrical consultants, HVAC consultant, that we should look into optimizing our buildings to, help India achieve the commitment at COP26. Next, please. And the best way is to optimize your design, which is looking into climate responsive design, basically to design your building so that you optimize the use of natural resources, and at the same time also provide a comfortable environment to the occupants in the building. Next. So some of the factors, look into good daylighting, ventilation, have adequate shading, and, to select appropriate materials. So quickly, I'll take you through the project cycle. So this is a typical project cycle. You start the design, you move into conceptual design, develop design, looking into detailed construction, and the handover. Next. So generally, the sustainability consultant or the people who are looking into optimizing the design or looking into building performance, they are generally roped in once the concept design or the developed design is the stage is over, looking into detailed design. So they get the consultant in place to see. Next, please. Yeah. So when those consultants are hired, basically at a detailed design stage, the simulation model is normally prepared to validate the design. Next, Deepa. So modeling basically at this stage is just to verify the decisions that are already made. So at this stage, you can't even change the design, right? So you have a design in place, you model it to see whether that the design is meeting certain compliances or not, or how the design is performing, right? But you are not able to change the design. So it's very important that the designers, and when I'm saying designers, it's not only the architects. For me, electrical engineer, electrical consultant, plumbing consultant, HVAC consultant, they are also designers, right? So if these designers have the power of this simulation and analytical tools, it can basically help them to take the decision when they are designing their domain, their field, when they are designing the electrical design or HVAC design or even the building design. So having the power of simulation at this stage, move to the next slide, people. Yeah, can help us, achieve the maximum benefit at the minimum cost. So this graph, I think most of you must have seen, where, if we get into the design at the RFQ level or at the concept stage, then the potential to achieve a higher level of performance is high, and the cost to achieve that same level is low. But as we proceed into the design stages, as we move to the detailed design, and so the effectiveness gets reduced, and the cost to achieve the same performance, increases. So if we have to achieve our commitment, it's important that the designers also have access or have a knowledge of this tool, or can use this tool to compare or evaluate different options at early design stage. So the barrier, I think many of you have also highlighted the challenges. Some of you have said, it's they don't know the tool, or it's difficult to model, right? So that is the barrier, and we have also observed that barrier, and when we have talked to different designers, consultants, that in order to use a tool to evaluate different options, you need to work with that tool for maybe 1 or 2 years to know the in and out of the tool. As Krishnendu has said that, according to him, that system should work, but the simulation tool is not giving maybe the right result. Maybe there some inputs are not right. So in order to overcome this barrier, the courses that we have designed is basically we are summarizing our knowledge and saying that, okay, this is the tried and tested way if you want to evaluate or simulate different options, right? Because that we have done from the past couple of years. So that's what we thought, that, to design the course in a way so that the designers can actually take the benefit of these tools to compare or evaluate different tools. So basically, how to translate the software output to design results.
Sure. Yes. So thank you, Gurneet. So this is very important, right? How do we really translate that? And we mentioned in the beginning that we've completed more than 400 plus projects, and pretty much every project calls for compliance. Some of them call for if we like we said, if you are hired very much in the beginning concept stage, and you are able to give design inputs as well. So here is one case study we thought we share with you, where this kind of early design inputs were given, and it makes a good case study and a lot of things that we have learned working on this project that we'd like to share with you. So this was done 3 years back. You can see a 3D model of this project. This is a training come a residential center at a place called Khandala, which is not very far from Mumbai. For those of you who know it, the site was very heavily wooded. The building is about 50,000 square feet in size, and there were 3 blocks on the site. You can see 3 blocks over here in this. This is a screenshot of the energy model. You can see there are a lot of trees in it. Now, the goal of this project was to achieve a net zero energy for the entire campus. And our role was to see the feasibility for this project, whether it could achieve the net zero goal or not. So quickly giving you an overview, there are 3 blocks here. This one on the bottom is the training center block. It's a daytime occupancy building. The one in the center is a residential block. And so the way it would work is it'll be like a nighttime occupancy, and in the day, people would spend time in the training center. And on the far end here is the executive suites, which had both the residential space and the training space. So it was more like, you can call it like a 24-hour occupancy. Next context I want to give you is we came on board on this project when the design was already developed. And yet we were here to assess the passive design performance, and hence assess the feasibility of achieving net zero goal. Okay, so here is our methodology that we followed. So I'm going to show you the focus here was on envelope, right? And we looked at envelope as if we were going to optimize the envelope. That was how we did the analysis. And so that would give us assessment of how the envelope is already designed and if there needs to be some changes and where it could happen. So the optimization was done on all these points that you can see on the left: solar axis, shading devices, solar insolation, window wall ratio, wall material, roof material, daylighting, glazing, ventilation. And while we ran these different design options called energy conservation measures, we were trying to assess the impact on occupant comfort, energy efficiency, reduction in cooling, tonnage and energy, and then also first cost impact as well. And in this process, we were trying to look at the response curve. So this is the approach we took. When it comes to energy simulation, you can keep on running millions of simulation. So how do you know where to stop? How do you know what is optimum? This is the kind of approach we took here to look at a response curve and then arrive at what was optimum for the project. Now here is a summary, but then I'll show you a little bit of the process as well. The client really wanted to know what amount of insulation is going to be used in the project. Because in terms of architecture, everything was taken care of, the orientation, it had deep overhangs, and we need to spec a glass for this project. So basic climate responsive design strategies were considered in the project. And so having that in place, what's the U value of the walls? That is, what is the insulation we could add to the wall? So our overall design recommendation was this, that we're showing you in a nutshell. It may look very technical for those who are getting started, so I'll try to make it simple. So there are 3 blocks here, and we gave a set of U values. So this is a performance data. I'm not saying what inch of insulation or what kind of insulation, but we said that as long as your U value of the wall is going to be 0.33, and in combination with this kind of a glazing with certain LPD and the executive block being so on and so forth, you will be able to achieve the net zero energy goal. Right? So here was a set of design recommendations. Now it just looks like everything is summarized in one slide, but there's a lot of process behind getting to that one summary slide. Here is a snapshot of annual energy use reduction, but I think I'll come back to this after showing you the process of how we got to that. So I'm showing you analysis for this block. This is called the social block. This is basically the training center, right? And the first step was to look at facade solar gain optimization, and what is the extent to which the glazing is directly exposed to solar radiation. So did all of those studies. And then we looked at the impact of design options on reducing cooling demand, right? Envelope is a combination of various things. It is wall and roof and glazing and shading, everything. And then of course the orientation as well. So here we looked at wall ECMs. So the baseline that you see here is what was already done in the design. They had a block wall system with an external cladding, and we tried to assess like 3 different kinds of insulation thickness. And then we looked at, what is the response curve? When it comes to insulation, you just can't keep on adding as much as you want, because it will not give you the real value in terms of the energy use reduction or the cooling load reduction. So we arrived at what could be the optimum for that particular project and the different wall orientations that we saw. It came to 0.33. Here I'm trying to focus not on the details, but on the process. Similarly, we ran this for the roof insulation. And then we looked at the different glazing options, right? So this is the different glazing specification. And here you can see the response curve for glazing as well. And the optimum was 1.7, selectivity ratio of 1.79. And then we put together the final recommended case. Now this case is for the envelope attributes, right? All the technical specifications for the envelope. And then we assume that the LPD is going to be 0.5 watt per square feet, which is what we derived from looking at what the design specs were. The design temperature was 24 as per the client. That is what they desired. And we recommended that if they have ceiling fans, then the elevated air speeds can help them achieve the same operative temperature, but then you design it for 26 instead of 24. Right. And then here is the impact on annual energy use reduction. This is only for that social block. So, scenario 2 is where you consider elevated air speeds. And so we had like about 29% reductions. And then load reduction was a lot more. So here you may not always see the impact on energy as much, but here the impact on load was much bigger than that of the energy. So that's where, using metric that matters really comes into play. It's not always energy, but here we also looked at demand, and we also showed them thermal comfort, how insulation really contributes to that. And so comfort is a different metric altogether. It may not directly translate to energy, but if you want to look at it in a holistic way, then we need to consider many different metrics for what we're trying to achieve. And then looked at the potential of PV on the rooftop of this building. Now, similarly, we did this. I'm skipping through this because I want to show you the methodology. We did the same methodology for the other blocks, executive block, and then the residential block as well. And then after we did all this, we arrived at what looks like this here. This is for the entire project. Baseline so this is the electrical demand reduction, annual energy use reduction. So this is a breakup of every block, peak cooling reduction. And then here is the slide that shows you at which point you can achieve the net zero goal. So with scenario 1, you can achieve the net zero if you have PVs on all the buildings. But if you only have PV on one building, which is a social block, which is what the client wanted, then one of the buildings can be completely net zero, the energy can be offset, but the other building, which is shown by the red block, executive, nearly zero, but the residential block cannot be offset. So here are different scenarios on what could be achieved with the different design recommendations that we showed them. Now, all of these recommendations is just based on the envelope, right? And that's what we want to show, bring to you, that finally, right sizing envelope is really important. It is key. It's not always right sizing equipment, which is also important, but right sizing building envelope requires a certain process and a certain rigor. And having worked on many projects, we've come to understand what could be the process that one could implement if they were looking into right sizing the building. Often, this is a missed opportunity because of lack of budget to hire a consultant, or lack of it being mentioned in the brief explicitly, and so on. So what if we could teach you how to do this for your project during early design stage, instead of so you can overcome the barriers of having to hire somebody to do something very simple, which one could do on their own. Building energy simulation tools can do many, many different things, but it's not that every project calls for very complex simulation runs. Often there are very simple questions like what should be the window wall ratio, what should be the orientation, what glass can I select for my building. These are very simple questions. We believe with our, the firm has been around for 20 years now. So our observation has been that if this decision making is in the hands of the building designers or the core design team, then we can really try to achieve the global or the national level benchmarks of net zero emissions and so on. So that is how we will need to accelerate our effort to design buildings which are climate responsive. Yeah, so with that we come to leveraging the whole building energy simulation tools. Gurneet, would you like to speak a few of these slides?
Yeah, sure. So I think we have got a great audience who are already working on simulation tools. So these are some of the whole building energy simulation tools, Design Builder, Open Studio. I think people are aware of Design Builder, ISV, eQuest, and Grasshopper plugins. Uh, Curve tool and Open Studio must be a new one new entry for these people. Yeah, so Open Studio was developed by an REL. It is basically, it works in both Windows and Mac. It has got it backend at Energy Plus and Radiance. And the other advantage is it's an open source tool. Yeah, and the I have been using Open Studio since 2014, and I am an architect. The positive points that I see of Open Studio is that one, it has a plugin for SketchUp, so you can easily model building geometry. So I believe in the first the Mentimeter question, somebody said that it's difficult to model, or data entry is a difficult. So in terms of building a geometry, it's pretty fast compared to other open source tools like eQuest and other tools. So it's pretty fast. The other thing is it's still under development, but yes, the same model can be used for daylighting, and it has Energy Plus at its back end. So you can, if you want, you can get details of each and every room, from energy usage to electrical usage, and you can also get details of daylighting for that tool. Uh, the other positive point is they have a huge library of measures and components. So measures are tools or macros. You can correlate it with the macros of your Excel developed by various people, which you can just drag and drop. So you need not to get into, like, there is one measure where you, if you want to model chilled water system, or you want to model VRV system, so you only have to drag and drop that measure, and the code itself will change your model, and will model central plant or VRV. So as an architect, you need not to get into that detail, how to model, what will be the connections of chiller, central plant with cooling tower, what should be the efficiency. So these things comes very handy when you are comparing or evaluating different design options.
Right. So I'd like to say here that some of you are getting started with energy simulations, and you might also wonder that what is the right tool that I need to start. This is a very common question we get asked a lot of time. So here I want to just share my experience. This is going way back into 2009 when I was in grad school. I learned like about 7 different computer simulation, like whole building simulation programs. And then uh, I was just building skills, right? Learning different tools. Then I came into the industry to work, and I learned 4 more tools while I was working. And then, and fast forward to now, there are many more tools which have been launched and which are being used. And so all of these 11 or 12 tools that I know is not something I use today. But what I have learned is either learn getting an idea of the framework of how to use any tool. That is what is the most important thing. So all of you, as you progress in your career, you may not end up using the tools in a very hands-on way, when you become very senior, but you will be able to understand the outputs of the simulation and communicate that to the client. Probably that will be most of your role. So that starts with learning the tool in the right way. And that's where we bring to you the whole Open Studio series. This is online instructor-led training program. There are 4 topics in this series. all of them use Open Studio. Why Open Studio? Even we as EDS, we use many tools. A lot of them, are paid tools. But we thought that Open Studio is one option. First of all, it's open source. So anyone who's beginning to start learning energy simulation, you don't want to go and buy something off the shelf. Simulation tools are expensive, right? So why don't it's Open Studio then makes a great case of getting started with energy simulation, learning how it works, and then you can decide whether you want to invest further time and energy in really doing a deep dive into it. Then you go and buy licenses for other tools which is available out there. We ourselves use Open Studio for both compliance and design assistance as well. So Hardik is asking framework of what these software actually do. Nobody teaches that. I agree, Hardik. We are coming from our experience. As a student, I've come from the experience of having been a student and having, being into teaching for 10 years. Gurneet has also been into teaching for as many years. And we know that this is what is not being taught. And we feel that as practitioners, we are able to bridge that gap. So we don't just want you to learn a tool, else you can have a demo video, which is, you can find many of these in the internet to learn, just to learn how to use Open Studio or how to use SketchUp. But how do you read the results? What do you make of them? If you are the a designer, how do you take it back into your design and make some changes? If you're the resource person to recommend, then how do you read the results to recommend a design option to the other person? Or how do you convince the client to go with your option A versus option B? You want to learn all this, right? So we've put together a framework which will help you do exactly this. And I'm not saying that this is
from my office.
Sorry?
Nobody teaches that framework of what we're talking. Sometimes it feels like these tools are simple data entry software like MS Excel.
Correct. So yeah, we have seen this where hello, sorry, someone is speaking. All right, so we understand that this is a practical challenge, and hence we've designed this course keeping that in mind. So there are 4 courses I mentioned. First is building envelope optimization using Open Studio. It starts on Monday, and a lot of you here are interested to use simulations in the best manner possible, and you shared your challenges, and you want to overcome those challenges, right? And for that, keeping that in mind, we have designed this program. It's a 2-week blended learning program. We have a special offer. If you want to register for it today, you've attended the webinar, you've taken out the time to understand what this is about, how simulations can help you in doing your work better and making an impact. And so we have this special offer here to sign up for the webinar. It starts on Monday. What is it that you will learn to do at the end of it? You will understand the impact of form, orientation, window wall ratio, shading, material selection, building energy use. You will learn how to create the response curve that I just showed you in my case study project. You will learn how to do this for your project. You will be able to confidently use technical data to support your design. You will be able to know which design strategy works and why. And of course, all of this you will learn with a hands-on experience. Further, you will know the workflow, which is ideal. See, energy simulation is very extensive and it takes years to sort of master it, right? But it should be broken down into digestible chunks, as I would like to call it. And so I've attended some programs which promises everything and, everything under the sun that you could learn in 2 weeks, but it really doesn't work that way. We have to learn in a methodical way, in a manner that you can actually work on your project. So in this program, the framework that you will learn, you will be actually able to apply it on your project. And this program is designed for working professionals. There are only 2 webinars in a week, and through the week you also have some videos to go through. So it gives you the time to actually, if you want to work on your project, you can do that. And then you can come into our classroom hours and discuss that with our course instructors who can give you feedback on your project if you want to go that extra mile and actually take out the time to apply it on your project during the 2 week of the program. Else, the way we have set up the assignments and the structure, it helps you to actually achieve all of this that we are saying here. Ishwin is saying, I just want to know how many hours are these courses. So you are expected to put in about 10 to 12 hours in a week. This includes the working on assignments and attending the 2 webinars in a week. And it's a 2-week program. So in a total, you're attending 4 webinars. It can be easily planned. In fact, I can just share this link with you over here really quick. So you can get to see the schedule. Let me share this. We have a whole calendar of different courses that we're running through the year. Right. And let me show you this building envelope optimization. So here is the link to the course specifically. And here is the schedule.
Deepa, I mean, if you have some of the reports prepared by our past participants, it would be also good to show them the output.
Okay, let me pull that up.
So Archana has asked whether we can take a session for College of Architecture. Yes, we do conduct sessions for students at different colleges. The only thing is we need only interested students who are really interested in learning simulation. So we can definitely look into that.
Yes. So here is an example of some of the work done by our participants in our course. Like I said, there are assignments in our program, and there is also capstone project, which is an optional thing to do, but this is where you get the most mileage for your money and the time that you invest in it. So here you can see this is from done by, so you will develop a building optimization, envelope optimization report. I'm going to scroll through it so you get a sense of what is it that you could develop at the end of the course, and you can take your own project as well. It may take you more time to develop it, but you know, that is what this course is about. You have the option to apply the concepts in your own project. Here, the 3D that you see is the project that we have given to be worked on. It's a sample project, and you can see here how the participant has come up with the optimization process, how they've come up with the curve and then identified what would be the preferred orientation. Similarly, for window wall ratio, this is the optimization, right? And you can see it is very detailed, looking at shading, window wall ratio, I showed you that, looking at roof insulation or roof section options and the impact on energy reduction, right? Here you're looking at wall assembly options, and then a conclusion on it. So in any project, this is what you want to arrive at, right? This is the kind of inputs you either want to give or you want to bring in into your own design. And this is something very doable by the project team themselves. So here the conclusion was align the building to a certain orientation. What should be the window wall ratio? What should be the shading depth? These are very specific outcomes after studying the simulation outputs, right? So this is an example. Here is another participant who developed her report. You can see here how, you know, she did the climate analysis to support basic approach towards passive design. And then she also looked at this orientation options. Clearly, you can see here, this kind of a result you will work on yourself. You will need to create these plots. So we teach you how to do this. If you can do it on a simple project, you can do it even in a complex project. So there's a question in the chat, how to cross-check our simulation results. Is there a rule of thumb? So there is no such rule of thumb. We actually discuss how to do this process, right? And in the discussions, in the question and answer that we do with you, you will be able to understand that, whether a result, how to judge whether the result is correct or there are errors in it, and so on. uh, right? So we show you the method of doing this, and so that gives you the leverage to get started on your own. So here is her report, right? So I can show you maybe one more example. Kiran is saying, I'm interested in Grasshopper. So yes, Kiran, we do have a course on Grasshopper as well, which you can look into. It's there on our website. See, this is our website, and we have live online courses here. You can see every month there is a program. And now in May, we are coming up with building envelope optimization. And then in September is daylight simulation using Grasshopper tools. So I'll again put this link in the chat, and you can register for it even now, even though it's coming in September, registrations are open. So if I would highly recommend that, learn the building envelope optimization process and see how it benefits you in your project. And then you can try and then explore further to look at lead compliance modeling and all of that. That is slightly advanced. So when you're starting out, building envelope optimization is the right program to get started with. It gives you the right platform, not just understanding the tool, but also to apply in your projects. Our whole aim is that you are able to apply in your project. So we are here to handhold you through that process. So I'm showing you the program schedule. So in a week, you have webinars on Tuesday and Thursday. It is after typical work hours, so 6 to 8. And rest of the days of the week, you work on the assignments that you've been given and the lessons, that is the videos that you have to go through. So you have, it's a nicely paced program without burdening too much. And then you also have the weekend to work on this, right? So overall, you're looking at like a 12-hour sort of a workload. You are free to explore further as well. And there are participants in our courses who have really done deep exploration, and we've given them that time and feedback on their project as they've worked on it during the 2 weeks of this program. So here is the schedule for that. If you have any questions, please feel free to ask. I'll again put the link in the chat for the enrollment here. So I'd like to tell everyone that, our series is there, right? Open Studio series, and they have been planned such that you have a month's gap between every program. Ashwin is saying webinars are recorded. Yes, you will have access to content beyond the program as well, and you will have access to webinar recordings in case you happen to miss them. So every month we have a program. So you building envelope optimization comes in May, and then the next one, which is daylight and thermal comfort, that comes in June. So these are, through the 4 programs, we are covering every component of this building design that one will need to learn. And it is comprehensive. So we have broken it up into 4 programs. And as you come to every program, you also get to brush up your skills or, working knowledge with Open Studio. You get better with every program. And you learn the next sort of topic that you're going to work on. So the second program is all about daylight optimization and thermal comfort optimization. And these are considered to be intermediate level courses. What it means is you may not know Open Studio, which is okay. In that sense, it's beginner. But then the technical terms and all of that, you might have to be familiar with it. And if you aren't, then we have modules even for that. So it's a, so you get started with this. So second course is on daylight and thermal comfort optimization. And then in July, we have lead compliance modeling for chilled water system in Open Studio. And then further in August, we are bringing a lead compliance for VRF system in Open Studio. Chilled water system and VRF are, you'll mostly find most projects having these systems. So we are teaching you how you can model the system with lead compliance for the purpose of lead compliance. Now, even if you're not into lead compliance, you can still learn about modeling the system and optimizing the whole building energy, right? Nimisha is asking, as a beginner, which software we should start with, Grasshopper or OpenStudio? See, both are different. Okay, Grasshopper fundamentally it's built very differently, and OpenStudio is built differently. Nimisha, as I understand, you are an architect, right? You've come for our CRD program as well. Yes, so Nimisha, you can unmute and speak. Are you able to unmute?
Yes,
Yes.
yes. Hi.
Hi,
Yes,
Nimisha.
yes, I'm an architect. Yeah, and I am even appearing for IGBCAP now, and I'm trying to learn more about green buildings. And side by side, I'm thinking to get this kind of knowledge to where I can actually incorporate the knowledge in the software.
Right.
Through the software, I mean.
Correct. So Nimisha, for you, OpenStudio will be the best thing. Okay.
Okay.
Again, the very important point being it uses SketchUp, which you probably are already using as an architect, right? To
Yes.
build the 3D.
Yes.
And it uses Energy Plus, which is what is not known to you, but that's what it uses to run the simulations. So, and you know, the 4 courses are covering most aspects that an architect has to address, which is building envelope and daylight and thermal comfort. HVAC systems is really optional. If you are not going to work with it on day-to-day basis, then we don't recommend it. But with this course 1 and course 2, you are covering all the main things that you would actually touch upon as an architect. And in the future, when you go on the path of maybe becoming a consultant, or generally as a green building specialist, you would want to learn these things. Grasshopper, I personally feel, has a little bit of a learning curve. And again, Grasshopper itself is open source. And we give training for, at the moment, only daylight. Not for the entire envelope optimization. That's slightly, there are different plugins to be used for that. It is slightly different, and calls for more time kind of spent in that. So I would say go with OpenStudio, dabble with it, and then build on it, as work on projects using this, and then go forward and take more skills, like build more skills in like a Grasshopper, so that there is diversity. I mentioned that I myself had learned 12 tools. So when you're starting out, it's good to know more than one tool, but you have to choose. Then for you, I recommend Nimisha, OpenStudio.
Okay. Thank you.
Sure. Yeah, are there any other questions? Please send it in the chat box. The special offer that is there, it's only valid for today, because you have taken out the time to attend the webinar. The course fee is 8,500, while the offer here is for as low as 5,800. So please make most of this opportunity. You are welcome to even go for this bundle course, which will give you a steeper discount than enrolling for a single course. So here again, I'm sending this link to you in the chat. Hope you will register and take your meet your goals of picking up the skills in the most practical manner as possible. Okay, so if there are any questions, please do ask them. Any question is fine. Everything is valid. No question is too simple. Any questions? All right. So I don't see any further questions here. So I'm assuming everything is crystal clear. So the links are here for you to check them out. If you have any questions on the course content, please let me know. I can show you more examples if you want to see that. Yeah, feel free to ask anything. Okay then. So since they aren't okay, there is a question. Yes. All right. Thank you, Ishwin and Nimisha, and thank you everyone for attending today's session and for your questions. We hope to see you in our cohort, and we can assure you that you will be learning in the most hands-on way as possible. So with that, let's close today's session. Thank you, Gurneet.
Thank you, Deepa, and thank you everyone.
Yeah.